In this video, we're going to be looking at limits graphically. And our example says evaluate the following given the graph of the function h of x below. And then on your sheet, you should have a bunch of all these wonderful values to find. And it's interesting to note that in this left-hand column, we're simply doing function evaluation. This is not limit notation. We just want to find the corresponding value of h when x is -4. But for all the rest of them, we'll be investigating the limits. So let's take a look at A, and we're gonna discuss here what is happening when when x is -4, and we're going to be taking a look at h at -4. So x is -4, and we can see here that even though there's a point listed, it's definitely not a point that exists for the function. So you could say does not exist, undefined, one of these things. Maybe we could write DNE, does not exist. The function does not exist here at -4. If we look to the right, we're going to evaluate the limit as x is approaching -4 from the left. So in this case, we can come from the left and we can get close to this value right here of -4. And we don't care anymore what happens exactly at -4. We know that the function's undefined there, it doesn't exist. All we care about is what y value is this getting close to. So if we come from the left, you can see that as we go to the right towards -4, so this is the left-hand limit from the left, it looks like this marker here is leveling off or getting close to a value of 2. And you can see that even this missing point here, we're given that the y value is 2. So this is definitely 2. The limit as x approaches -4 from the right, so we can come from the right and we can see what value we're getting close to, and the value, remember, is the y value, or the output, or h of x in this case, and that also is 2. If we want to make a conclusion about the limit as x approaches -4, there is no negative or positive sign here, so this is just the regular limit, and for a limit to exist, it needs to be the same from the left and the right. We can look here, the limit as x approaches -4 from the left and from the right is definitely the same thing, so we can conclude that that limit is 2. If we look at the next set of numbers, we've got h at 1. I'm going to move this over just a little bit so you guys can see this. So we're here at h at 1. And what we want to do is we want to find out what is the value of h when x is 1. So let's look at that. Here it is. There is x at 1. Down here, this function does not exist when x is 1, but up here it does. And so the output would be 4. If we take a look at the limit as x approaches positive 1 from the left, we're going to follow along with that graph, and we can see here that as we get close to this point from the left, the y value here is 4. So it's just the same as when we evaluate the function. Sometimes it works like that. From the right-hand side, though, so as x approaches 1 from the right, we're going back up a little bit here, up a little bit, and even though the function doesn't exist here, we just care about what value we get close to for y, and that value here is -2. So we can write -2. If we're making some decisions now, if we want to talk about the limit as x approaches 1, the left and the right have to be the same. This function, though, or the limit as x approaches 1 from the left, is different from the limit as x approaches 1 from the right. So we can say that the limit itself for x approaches 1 does not exist because it's different from the left and the right. The next one we're going to take a look at here is h at 6. So h at 6, we're just looking for what is the output when the input here is 6. this spot here, this point is moved. It looks like it's moved. It doesn't exist here, and that output is actually 2. So this function does exist when x is 6. There's totally a point right here, and the output is 2. Let's take a look at some of the other limits, though, and we're going to take a look here at the limit as x approaches 6 from the left. We'll take a look from the right, and then we'll see what we can conclude about the limit as x approaches 6. So from the left, it looks like we're rising and getting close to a value of 5. I'll write that down. And from the right, it seems like we're getting close to, in this case, we're descending and getting very close to, again, this value of 5. So from both the left and the right for this one, we are approaching a value of 5. If we are approaching a value of 5 from both the left and the right, then the limit, as x approaches that value of 6 in this case, will be 5. Now that seems a little bit silly because the limit is 5. The value the function's approaching is 5. Well, it definitely is. I mean, from each side of the graph, we're getting close to this value. However, if you were asked to evaluate the function at 6, it's 2, and these numbers can be different. The actual value of the function may not be what the limit is. This is asking us what is the exact value when x is exactly 6, and this is asking us what is the value of function when x approaches or gets close to 6. Be very cautious with those kind of situations. If a function is continuous, then direct substitution will work. If it's discontinuous, then you have to look a little bit further, as this function is definitely discontinuous here at this point.